and then that'll cancel our denominators there. So we'll have, I did not put that in the right place. We have 2 times x minus 2 is equal to y minus 6. So then to put this in slope-intercept form, I just need to solve for y. So we'll distribute the 2. And then add 6 to both sides. So we have 2x plus 2 equals y. Nobody likes mx plus b equals y, so we'll turn it around and write it as y equals 2x plus 2. And now we have the equation of our line. So I don't expect you to reproduce it at this point, but does each individual step make sense? Questions? What's up?
I don't get why you put x and y in there. Didn't you just know the points on the graph?
So we could find other points on the graph. Like we could say, I know the slope is 2, and so if I were to go like over 1, I could go up 2, and I could create a bunch of other points. Like I could be like, this is 3, 8? And that's another point on the graph, right? And like using the slope, I could do that. However, our goal is to write the equation of the line. And the equation of the line always has an x and a y in it, which represent every single one of these points. So that eventually, like if we were going the other direction, and I started with this, then plugging in 5 would have to, well, that's not the right equation. Sorry, I'm mixing my. But if I started with the equation, if I had this, then plugging in 2 would give me 6 for y. And plugging in 5 would give me 12 for y, right? So I could use that equation to get the different pairs x and y. So what we're doing to go the other direction is we're starting with a slope that we know and a point that we know. And then we're using x, y as just a general solution. So sort of like, what day was it? The day before yesterday, remember that one where we put a and b in as x to like find the slope? I don't remember if I know where it is. So if we represent a point with variables, then we can say that this point represents every single solution on that graph. So every single point on that graph, which is what that x and y mean in the equation. Like every ordered pair, x, y on that graph has to make the equation true, right? So we're forcing the equation to be true so that we end up with something that has 2 variables in it and fits every point, like you said, every point that you know you can find on that graph. The way we've set it up is so that all of those points you can plug in for x and y here, and it'll be a true statement. So we're kind of just abstracting it into an equation. Any other questions? So, and that's one of the keys to this that can be a little bit tricky is that when we go the other direction, we're like trying to get numbers. Like we're starting with variables and trying to get to numbers. And here we kind of have to start with like solid numbers and like introduce variables so that we can have variables in our equation when we write it. So we're going to now generalize this process. So rather than doing a specific example, we'll just put more variables in. So let's assume, like I said before, in order to write the equation of a line, you need the slope and you need a point. So we're going to assume that we are given that the slope is m and a point. We'll call it AC. So I'm using a different color just so that you know what parts are like would be given to you in the problem. So like in the problem, they would like give you a number for M and they would give you numbers for A and C. So even though we're representing them with letters, They won't end up being variables in specific problems. So on my graph, I'm going to ignore this guy because I only need 1 point and say, here's the point they gave me. AC. And then that XY is going to stay as my general point, where my X value is just X, my Y value is just Y. Keep in mind that in your final answer, you have to have an X and a Y. You have to have those variables in order for it to be an equation for the entire line and not just specific points on it. So back up to the top to my slope formula. We're going to write the slope of the line that passes through those 2 points. So remember that slope is the change in y. So in this case, that is y minus c. So that's our vertical change. And then divided by the change in x, which will be x minus a. So that's our horizontal change. And that has to be equal to the slope that we were given. So 2 points on a line, slope formula equals our slope. And again, this doesn't really look like the equation for a line, and so we're going to clear fractions. We're going to multiply both sides by this x minus a. So we end up with m times x minus a equals y minus c. And this is what we refer to as the point slope form of a line. Point slope form isn't like, it's not a form of a line that somebody's going to be like, here's an equation for a line and it will look like that. You won't ever see a line in that form. It's just sort of a preliminary form that we use to get to the equation of a line using the point or the slope in a point. I remember to this day when I learned point slope form of a line, it was in like a box that was shaded in our textbook and it had a bunch of variables in it, and like we were told to memorize it, and I could not for the life of me memorize it. Like, I'm a horrible memorizer. But there were so many X's and Y's and N's and all this stuff floating around. It took me years to figure out that the point slope form of a line is just the slope formula. Like, that's all it is. It's the slope formula with the fractions cleared. And so I don't want to tell you guys to memorize this. Like, I would rather you just start here, clear your fractions, because that slope formula is something you already know, and there's no need to cram your head full of more stuff when you can use what you already know to get there. Eventually, when you start to see this pattern and kind of internalize it, if you skip that step with the fraction, that's totally fine with me. I just would rather you see that pattern than try to like just do rote memorization where you'll get stuff mixed up and things like that. So let's do some examples. Yep? Number 2. So we're going to find the equation of a linear function which has slope -2 and passes through the point 1, 8. One thing I noticed when I read this initially is that it has that word function in it, which just means that I'm going to switch y to f of x at the end. There's nothing mathematical about that, like in the sense that we're doing calculations or we have to like manipulate anything. It's just literally like a switch. So it's just a notation switch. So we're given our slope, which is m, is -2. And we're given a point 1.8. And so what we're going to do is we are going to write the slope of the line that passes through the point they gave us, which is 1.8, and our general point, xy. And again, just using the slope formula. So my slope formula is m equals the change in y, so y minus 8 over the change in x minus 1. However, we know what the slope is, right? The slope is -2. And so instead of writing m here, I'm just going to put that -2. And this point right here is like the point you're trying to get to when you're setting up these problems, where you have numbers for everything except the x and the y. The input and output of your function are the only things that should be variables at this point. So now we can clear fractions and solve for y to get our equation. So we'll multiply both sides by x minus 1, which gives us -2 times x minus 1 equals y minus 8. Distribute. And then add 8 to both sides. And then remember, we're going to just switch that y out for f of x. So just instead of writing y, we're going to write f of x equals -2x plus 10. How might I, so if I'm taking a test and I had this problem and I did all this work, how might I know if I did it right, like if I got the right answer? How could you check?
Plug in the x and y values.
Mm-hmm. Yeah, like if you took x equals 1 and plug it in, and if you get 8, then you know it's true. Or if you could plug both of them in and see if you get a true statement. So if we take 1 and we plug it in for x, we get -2 times 1, which is -2, plus 10 is +8. So our line does in fact go through the point they gave us. And then the other thing to check, which might seem kind of obvious, but it's one of those things, again, like I was saying yesterday, when you're rushing through a test, you can miss these things, is make sure your slope is right, too. Like once we get it into y equals mx plus b, make sure that m is actually -2. After you've done calculations, sometimes you can drop a sign or something like that. So if your slope is correct and that point works in your equation, then your line has to be right. Like there's no way to get the wrong line and have both of those things work. So it's always nice when there's some problems on the test, you know if you got right before you turned it in. So that's a good way to check. You can also use that thing I showed you the other day. How are we doing? Okay, let's do another one. So one of the things that can be tricky about this whole process is it seems like there's like a million different kinds of questions, right? Like they can give us the slope and the y-intercept, or the slope and a point, or 2 points, or perpendicular, like all these different things, which makes it feel like there's lots of different things to do. However, all of these problems are basically the same. The only thing that can vary is the way that they give you the slope. So in the previous problems, they just told us what the slope was. Here, they don't tell us the slope, but they give us 2 points. So the first step is to find the slope using the slope formula. And after that, we're right back in the same situation we were at in example 2. So the only thing that varies is how you get the slope. Once you get the slope, you've got slope, point, you do exactly the same thing every time. So we're going to start by finding the slope of the line that passes through those points. So we've got m equals the change in y over the change in x. So negative 4 over 4 is negative 1. So we've got our slope. And then as far as the point goes, they could give you 500 points on the line. Once you know the slope, all you need is one more point, and it doesn't matter which one you choose. In this case, I'd probably use 2, 3, because it doesn't have any negatives, and so I'm not going to screw up with the negatives. But it literally doesn't matter. You just pick one of the points. So we'll do m equals negative 1 and a point of 2, 3. And then we'll do the same process we did before. One thing you can do if you find yourself getting like mixed up about what goes where in that fraction is if you take this piece right here and say, okay, I have negative 1 minus 3 over 6 minus 2, and I found that that was equal to negative 1, right, which is just what we just did over here. And then just replace the negative 1 and the 6 with your x and y. So that negative 1 was the y value of my second point, and the 6 was the x value of my second point. So I just like turn this point into xy. And now I have it set up exactly how I want it, and I can clear fractions. So y minus 3 equals negative 1 times x minus 2. Gives me y equals negative x plus 5. I skipped a step, but if you distribute the negative 1, you have positive 2, right? And then add 3, gives you that 5. Any questions? Okay. I was trying to save paper. So I have a colleague who bugs me about saving paper all the time. And so when I was doing all the spacing, I totally messed up the order of things. So we have to skip down to parallel lines before we do the problem that involves parallel lines. So just skip 5 here for a second, and we'll come back to it. So to the extent that we're talking about parallel and perpendicular lines, I promise that we're not going to do like any geometry. But it turns out that giving the equation for a parallel or perpendicular line is just another way that we can give the slope of a line when we're trying to write an equation, because they have interesting relationships. So what are parallel lines? What's that mean? For two lines to be parallel.
Two lines that never touch.
Yeah, they're lines that never intersect, right? So like railroads. What can you tell me about the steepness of those two lines? Yeah, they're the same, right? And it kind of makes sense, because if one line was steeper than the other one, it would like eventually overtake the other one, and so they'd eventually intersect. So the only way for them never to intersect is for them to be growing or declining at exactly the same rate, which means that their slopes have to be the same. So parallel lines have the same slope. Which means that if I give you the equation of a line, and then I say write the equation of a parallel line, you can get the slope of the first line from the equation, and then just use that same slope to write your equation. So backing up, back to example 5, we're going to find an equation of the line containing the point negative 1, 3, and parallel to the line 2x plus y equals 10. So the situation we're in here is like, we're told that there's this line that has the equation 2x plus y equals 10. And then we're given this point -1, 3 that's like over here somewhere. And our goal is to come up with the equation of, that's not a line, of that line. So the line that's parallel to the first, but passes through that point that we're given. So the first thing we're going to do is look at this equation over here and just put it in slope-intercept form. So just solve for y. So we have y equals -2x plus 10. So what's the slope of that line? Yeah. Which means the slope of the red line is also -2. So now we're back to where we were in the previous problems, where we know a point and then we know the slope. So we have m equals -2, and our point is -1, 3. One thing to keep in mind about these problems is that that equation only gives you information about the slope. It's really tempting to try to like do something with that 10, but that 10 has nothing to do with the other line. So if you look at the graph, like we see like there's a y-intercept of the first line up here, and the y-intercept of our line is down here. Like they have nothing to do with each other. And so once you get the slope from that equation, just throw that out completely. It does nothing else for us in terms of writing the equation. So this guy's gone, and I'm going to have you guys finish the problem and write the equation for that line using your slope and your point. Are opposite. Meaning they have opposite signs. But then one other thing happens as well. If we think about slope as the change, the vertical change divided by the horizontal change, if I have the horizontal change here, what happens to that when I turn it 90 degrees? So you've got a horizontal line, and you turn it 90 degrees, and it becomes a vertical line, right? So what is the horizontal change for one of the lines is, horizontal for that one, is the, where do I want to put it? Vertical change for the other one. And vice versa, so I'll use a different color. So you can kind of see that if you take that little triangle, the red, green, and like turn it 90 degrees, it becomes like the rise and the run of the other one. So what was the vertical change becomes the horizontal change, and vice versa, which means if we think of it as a fraction, we're flipping the fraction over, right? So vertical to horizontal. So in addition to being opposites, we also have reciprocals. So they have both opposite sign and the fractions are reciprocals. Lily, was that your class where we played the Missy Elliott song?
Yeah.
You guys Missy Elliott fans? The flip it and reverse it song? You can get it stuck in your head before the test. And every time I teach this lesson, like I have it stuck in my head for like 2 weeks. So that'll be fun for the next 2 weeks. But so we flip the fraction and then we reverse the sign to find the slope of a perpendicular line. And again, we're going to use that information the same way we use the fact that parallel lines have the same slope. It's just another way of giving information about a line. So if we, where'd that one go? Is your guys' number 6 the same as my number 6?
Yeah.
Okay, just making sure. I think I got it from a different file. So here we're given, again, the equation of a line, a point, and then we're told that that line is perpendicular to the line that we want to write the equation for. So we've got like a line here. No, it's going to be positive. And this is our 4y minus x equals 20. And then we're given a point, like 2, -3 is down here somewhere. And just like we did with the parallel line, we want to write the equation of that line right there. I made their y-intercepts the same, which actually turns out to be accurate on this problem, but is a coincidence. It's not true every time you do a problem like this, that their y-intercepts will be the same. So go ahead and see if you can write the equation from the information given. And the fact that you know the y-intercepts is the same, or the same, is a good way to check if the answer's right. So start by finding the slope of the perpendicular line. Then use that opposite reciprocal fact to find the slope of your line. And then from there, same process as the other ones.